Greetings and welcome to W4U4 Implementation of Problem Based Instruction Part 2 and comparison with project based approach to instruction. In the previous unit, we understood problem based approach to instruction PBI. In W4U3, we looked at the key features of PBI. In this unit, we will discuss implementation related issues of PBI and then compare PBI with PjBI. So, the outcomes for this unit are understand the implementation issues and guidelines in the context of PBI in engineering programs, compare PBI and PjBI. Entire programs in medical profession have been designed using PBI in some institutes. In fact, as we saw last time, PBI arose in the context of medical education, and several institutes have designed the entire programs in medical profession based on PBI. However, such an approach is quite rare in engineering programs. Implementing PBI in engineering programs has several practical and challenging issues. Many of these issues are similar to the ones we discussed earlier in the context of project-based approach to instruction. However, some issues are unique to PBI, but there are many similarities also. Institutes need to experiment and decide on the extent to which they wish to incorporate PBI into their programs. What are the situational and implementation issues for problem-based approach to instruction? The first is large class size. PBI works best with only small groups, about 5 to 7. This means that implementing PBI across large classes or entire departments is logistically complex. Promoting PBL requires only small groups, and if the class size is large, then there are logistical issues. We need to create small groups and make all the groups work on the same problem. Provide multiple sets of resources to reduce the burden on the instructor. This is not a theoretical requirement, but it is a pragmatic requirement. The instructor would find it almost nearly impossible if each group is working on a different problem to implement PBI. So, we need to provide multiple sets of resources. Let the teams stay together for multiple problems so that they can realize the benefits of collaborative work. Strategies are required for managing the large number of small size groups. Each group is only about 5 to 7, but there are several such groups. So, how do you manage such groups? Learners facing PBI for the first time. Prior training has made them teacher dependent and generally passive learners. In the earlier classes, they are accustomed to passively receiving instruction material from the teacher. So, they are teacher dependent learners. But now they have to become autonomous learners, self learners. So, they may be very uncomfortable with PBI because they are facing such a situation for the first time. So, learners facing PBI for the first time may be uncomfortable with PBI. Articulating the understanding, engaging in independent research, and working in groups may appear to them as too much burden. They are accustomed to simply sitting in the classroom and listening to the material presented by the instructor, then somehow manage the exams. But now they are supposed to do many things like articulating the understanding, engaging in independent research, and working in groups, and this may all look like too much burden. And anxiety over lack of clear right answers. Because PBI does not demand any clear right within quotes answer. What is important is that the learners engage with the problem and learn from it. And this absence of a clear right answer makes the learners anxious whether they have obtained the right solution, whether they will get good grades, whether it will be acceptable to the instructor. These are all issues that plague the learners. Then some of the learners may have poor self-regulation and poor abilities for time management, that is metacognitive issues. Preference for familiar assessment formats like quizzes and exams would also make the students very reluctant to adopt the PBI. There is also faculty resistance. Faculty members may resist shifting from traditional lecture based teaching due to lack of experience with PBI. And in PBI, the control rests with the learners. So the faculty may have fears of losing control of the classroom. Instructor must invest considerable effort in designing quality PBL problems and in scaffolding the students' learning process. In fact, we do not have too much experience with large number of quality PBL problems in engineering programs. Instructors must match the type and complexity of the problem with the maturity of the learners. So, instructors must judge the maturity of the learners, then must ensure that the type and complexity of the problem given to the learners is a matching one. This requires again considerable effort from the instructor. So, it requires a paradigm shift in teaching philosophy. Faculty may need training in facilitation, group dynamics, and assessment techniques. These are the areas in which faculty may not have prior expertise. So, they need to be trained. Assessment complexity is another issue. Assessing PBL outcomes, process, collaboration, creativity, etc., is more complex than grading responses in standard assignments like written fixed time examination. And need for rubrics covering transferable skills, including communication, teamwork, etc., becomes another challenge. Assessing individual contributions vis-a-vis group contributions is again quite challenging. Balancing summative and formative assessment is rather difficult. One can see that many of these issues have cropped up when we discussed project-based approach to instruction also. Curriculum and timing. Engineering curricula are often tightly packed with content and accreditation requirements, making it hard to fit in PBI because PBI needs more time, not only from the students and teachers, but also more time in terms of schedules. So, fitting in PBI may be difficult. Pressure to quotes cover the syllabus makes it difficult to adopt more time consuming PBI on a large scale. Most of the time, the syllabi are overloaded and the pressure on the faculty to complete the syllabus makes it very difficult to adopt PBI because PBI consumes much more time. Accommodating PBI in course schedule requires considerable flexibility in curriculum design, which is generally not available in most of the institutes. Nearly impossible in an institute that does not have academic autonomy. That is, so called Tier 2 institutes may find it very, very difficult to incorporate PBI into the curricula. There are resource and infrastructure limitations. Effective PBI often requires specialized resources. These include laboratory access, prototyping tools, necessary workshops for fabrications if required, collaborative spaces, etc., and good access to information search facilities. There are issues like this. Limited budgets and overloaded technical staff is also another issue. Then inadequate support for interdisciplinary projects. This we have discussed earlier also. Then scheduling conflicts for laboratories and team meetings. Laboratories is a limited resource and it will be used by regular students in the regular classes, in the regular courses, and scheduling the PBI activities along with the regular users again can be quite challenging. What are the guidelines for implementation of PBI? How can we overcome these challenges? First and foremost, faculty training is absolutely essential. So, organize faculty development workshops in PBL, design, facilitation, and assessment. Mentorship models have to be explained. Pair PBL experienced faculty with newcomers to co-design modules and co-teach courses. That is, the new faculty get trained in the PBA activities by matching faculty with PBL experience with the new faculty. Encourage faculty to pilot one PBL module or unit rather than redesigning the entire course immediately. Of course, this may not be appeal to purists because it's not a strict PBI approach, implementing just only one module, but it may be necessary. So, encourage faculty to pilot one PBI module or unit rather than redesigning the entire course. She can scale it up with experience. Notice that we are using PBI and PBL interchangeably because essentially PBI is what promotes PBL. Student orientation. PBL orientation is first required. So, offer workshops on teamwork, time management, and inquiry skills early in the program. Perhaps this needs to be done in first year itself. So, a lot of metacognitive training also needs to be provided. Scaffolded problems. Start with well-structured problems, then gradually increase the complexity and openness. PBI requires that the problems are complex, open-ended, fuzzy in order to be realistic. However, we can start with well-structured problems, then gradually increase the fuzziness as well as complexity and openness. Reflection and feedback. Build in regular reflection exercises and formative feedback to help students adapt PBI. Curriculum and timing. Modular integration. Embed short PBL cases, 1 or 2 weeks. Again, this may not be a complete philosophy of PBL, but embed short PBL cases into existing courses to complement rather than replace lectures. Notice that in all these solutions, we are not looking at PBI in a very large scale across all courses, across all departments kind of a scenario. We are looking at a more feasible approach to implementing PBI. So, from a pure theoretical perspective of PBI, there might be some deviations, but these things have been shown to work. So, these are practical solutions which are workable. So, modular integration, flipped classrooms, deliver foundational content via videos or readings, freeing the class time for active problem solving. This flipped classroom idea can be used for many other things also, and in fact, this plays an important role in all active learning approaches. So, for PVI also, we can use flipped classrooms. Program level planning. Integrate PBL only at selected points in the curriculum and keep the scale modest. As I mentioned, it is very difficult to adopt PBI on a very large scale in engineering programs, though it has been done in medical programs. In order to face the challenge of resource limitations, assessment complexity, one can look at the use of virtual laboratories. Today, many such solutions are available, and most of the time they are free and open source solutions. So, one can use virtual laboratories, other open source tools, and virtual meetings. Again, there are several platforms which are available, which are practically free or at highly subsidized prices for academic institutes. Rubric based assessment, develop clear rubrics to assess process, content, and transferable skills like communication. Share the rubrics with students upfront. Grade both group output and individual deliverables. Leverage technology as extensively as possible. This is extremely important. So, leverage technology as extensively as possible using virtual laboratories, virtual meeting places, open source tools. All these make it implementation of PBI less painful. Some of the critical success factors for PBI are total commitment of the instructors and the organization. This is absolutely essential, and unless the drive comes from the management and the organization is committing the necessary resources and the instructors are committed to the spirit of PBI, it becomes very difficult to make it a success. PBI must be implemented in its true spirit, not just assigning some problems to be solved by the students, the learning context remaining the traditional one. That doesn't help in the effective learning by PBI. Another key for the success of PBI, an extremely important one at that, would be extensive use of ICT at every process step. This is what just we mentioned in the previous slide also. Now, let us look at, we have seen two approaches, problem based approach to instruction and project based approach to instruction. Both have several similarities, but they are at different. So, let us try to compare these two approaches and see how they fare in the context of engineering education. The background, if you look at PBI, has its origin in medical education, 1969, McMaster University, Canada, and it continues to be used quite extensively in that and related fields, medical education, nursing education, physiotherapy, allied fields. Its use in engineering programs does not seem to be that extensive, though We have some significant studies reported in the literature. Project-based instruction, PjBI, based on the two key branches of constructivism theory, cognitive constructivism and social constructivism, has a long history of use in engineering education. Of course, in a limited way in the early usages, but at least it has been quite popular in engineering education for a very long period. PjBI is quite popular currently in engineering programs, and engineering educators generally seem to prefer project based approach to problem based one. Both PBI and PjBI are student centered and experience oriented instructional approaches. They promote deep learning and share several features. Yet, they are distinct approaches and they differ in purpose, structure, outcomes, and implementation. The similarities and differences between these two approaches have interesting and important implications for all the stakeholders. Where to commit the resources, which one to adopt, what is the extent to which one should adopt PBI, and what is the extent to which one should adopt PjBI. All these issues have some kind of relevance when we look at both of them. Focus and learning outcomes. From that perspective, if you look at these two approaches, PBI, the focus is on acquiring knowledge. So, the basic purpose, focus is acquiring knowledge. Engage in critical thinking and self-related learning to solve the problem. It's not the end product that is important. It is the focus is on engaging in critical thinking and self-directed learning. So, emphasis on the process of reasoning, research and collaborative inquiry. On the other hand, in project-based approach, focus is on creating an artifact that satisfies identified user needs. This is very important. The requirements have been decided upfront. So, the artifact created must satisfy those requirements. So, focus is on creating an artifact that satisfies identified user needs, acquiring and using the necessary knowledge and skills. Emphasis on the end product, its performance and validation. Process is valued, but in project-based approach, the focus is on the end product. So, if you look at the structure and process of these two approaches, PBI starts with a real-world problem scenario, often presented as a case study. The problems tend to be rather fuzzy. There is no predefined structure to the solution. This is very important. It's open-ended. And the PBI uses a cycle of asking questions, doing research to gather information, proposing a solution after critical analysis, refining the solution after group discussion, revisiting the problem, and so on. In a cyclic fashion, it proceeds through these kind of things. Whereas the project-based approach starts with an identified real-world requirement stated as a problem. The requirements tend to be rather vague, fine, but the requirements are there and the customers are there, and the team needs to turn the requirements into formal requirement specification document, interacting with end users when required. So, the team has to first focus on generating a formal requirements specification document. At the end, the final product is validated against this requirement specification. So, the requirements tend to be vague, but they become crisp and formal once the team starts work. Project has to be completed in a phased manner resulting in a product that meets the specified requirements, which means that it cannot be an open-ended research-based activity with no clear schedules for completing the work. It has to be completed in a phased manner within the stipulated time, resulting in a product. Roles of students and instructors, they change. PBI students are investigators and researchers who engage in inquiry, hypothesis formulation, and hypothesis testing. Instructor is a facilitator of learning, a coach and a tutor, scaffolding for the inquiry process. But the teacher is never a provider of content directly. The teacher may help in scaffolding, but the role as a coach or a tutor is not a conventional one. The teacher is never a provider of content. In the project-based approach, students are designers, developers, builders, and testers. Instructor is a facilitator and must evaluate the final product. So the roles of students and instructors do differ. Then project management principles, PBI really does not worry about project management principles. So it's not a feature of PBI in fact. Primary focus is on solving the problem, the associated process. Whereas for project-based approach, the principles of project management are extremely important. This constitutes important knowledge and skills that the students have to acquire and demonstrate. All the project management principles like scheduling, resource leveling, cost estimations, all these become very important. They may need help from the instructor with these principles because some of them may not be familiar with project management principles and they may not have been exposed to these tools and techniques in earlier courses. So they may need help. The instructor must provide the required help with the principles of project management and use of project management tools if such tools are planned to be used in the project. There are many such tools, both open-ended, free source and proprietary tools. End result in project-based approach, different choices are indeed possible for the student teams in building a solution. The final solutions can differ, but the solution offered by the team must be validated by demonstrating that it satisfies the requirements decided upfront. So that is the key feature. While the solutions can differ, all of them must satisfy the requirements and they have been decided upfront. So given specifications must be met. PBI insists only that the student teams must solve the problem satisfactorily. No other requirements are stated upfront. There is a significant difference between these two requirements. That is, specifications stated upfront and only stating that problem must be solved satisfactorily. These two are quite different. Comparison of the end result, if you see in project-based approach, the final solutions can be compared based on cost, performance, reliability, etc. because it is an artifact. In PBL, there is no such comparison. It doesn't have any relevance. Assessment, the criteria used by PBI, problem solving process, critical thinking and reasoning, depth of understanding, etc. In PjBI, product quality, innovation, resources consumed, research depth, such are the issues. Similarly, deliverables in PBI, problem solution, written report of analysis, group discussion, reflection journals, whereas in PjBI, physical or digital artifact. It could be a physical product, or it could be a software system, or it could be a mobile app, but there is a physical or digital artifact that is a deliverable one. Then project report, and then there can be several others. Similarities are both approaches are student centered. Both of them emphasize real world relevance. Both promote collaboration and teamwork. Both develop higher order thinking skills, and both encourage self directed learning. It is true that they have these similarities, but also we saw that they have several distinct features which make them separate also. So both these approaches are similar yet distinct. So in the next unit, we will understand the nature and use of scaffolding in instruction. So thank you. We will meet again with scaffolding in the next unit.